Hello physicists and welcome. In this session we'll be looking at an inelastic collision. That's a collision where the two objects do not separate after the collision. This is problem number 4 from the Conservation of Momentum and Collision packet. A locomotive, mass of 5,000 kilograms, rolling at 5 meters per second, couples to a stationary line of freight cars with a mass of 35,000 kilograms. Immediately after coupling, what is the speed of the train? That's the locomotive and the freight cars together. Yeah, let's take a look at what this means. When they end up coupling up, we have the freight car moving forward, and then the locomotive and the freight cars move together. Let's go through our 5-step problem-solving process. We have our train already drawn. What are we trying to find? We're trying to find the final velocity. What are we given? We're given the mass of the locomotive, 5,000 kilograms, the initial velocity of the locomotive, 8 meters per second. I'm giving that a plus, indicating it's moving to the right. We're also given the mass of the freight cars, 35,000 kilograms, and we're given the velocity when it says it's stationary. So we know that the initial velocity of the freight cars is 0. We also know that this is an inelastic collision because they couple and they move together. The objects do not separate after the collision. Let's look at our relationships here. In a collision, we know that for that brief instant that the two objects are colliding, there is no external impulse, so we know that the initial momentum is equal to the final momentum. We know that the initial momentum is the sum of the momenta of each of the individual objects. And in an inelastic collision, we know that the final velocity of our objects are the same as each other. So we're just going to call that a single final velocity. So we could put that as our final velocity is going to now be shared. Let's see. Sorry about that. Our final momentum is shared among all of the objects. So we can add up our masses and then just multiply that by a single final velocity. Let's go ahead and solve this problem. Let's take a look at our initial momentum is the 5,000 kilograms times our 8 meters per second plus 0. Our freight cars have no momentum because they're not moving. So we have initial momentum of 40,000 kilogram meters per second. That'll need to be our final momentum as well. So our final momentum is now distributed among the complete mass of the locomotive and the freight cars. So it's the 5,000 kilograms of the locomotive, the 35,000 kilograms of the freight car, all of that mass times our final velocity. And that's what we're looking for. Let's go ahead and we'll take our final momentum, that 40,000 kilogram meters per second. We'll divide it by the mass of the locomotive and the freight cars, 40,000 kilograms. Hey, so 40,000 divided by 40,000 is equal to 1. Let's figure out our units. We see that kilograms cancel, and we're left with a meter per second. Our final answer is plus 1 meters per second. That indicates that we're moving to the right. So for now, that's an inelastic collision, and that's physics.